Okay, let's talk about something that sounds like it's straight out of a sci-fi movie. Imagine a world where millions of tiny, intelligent things can see, think, and work together. Well, today, we're diving into the atomic lab, where a team is actually building that future. This is some seriously cool stuff.
So right off the bat, let's look at their big, audacious goal. They're all about advancing the paradigm of the AI-enabled Internet of Microthings. Now, I know that's a mouthful, but stick with me. It might sound like a crazy futuristic concept, but this isn't just a dream on a whiteboard. This is the real mission they're chasing every single day.
All right, so let's unpack that. What does a future full of these micro things actually mean for us? Let's get into the grand vision.
Okay, so think about this. We're not just talking about your smart thermostat or your smartwatch. We're talking about millions, maybe even billions of microscopic little robots and sensors just out there in the world. You could have them monitoring the health of an entire forest, tree by tree, or working together to fix tiny cracks in a bridge before they become a problem. The key here is they can sense, talk to each other, and coordinate on their own. It's really like creating a massive, intelligent digital ant colony.
So who are the people actually building this stuff? Let's go inside the atomic lab and meet the architects of this future.
The lab's name is Atomic, and yes, it's an acronym for something pretty complex. Auto-trajectory-oriented microsystems for intelligent coordination. Whoa, right? But if you break it down, it's actually a perfect description. They're making tiny microsystems that can move on their own, auto-trajectory, and work together, intelligent coordination. See? It all makes sense. So where is all this happening? The lab is part of the Hong Kong University of Science and Technology in Guangzhou, and it's headed up by Tingfei Chang. This is ground zero for all of this amazing work.
Now this is what I find so cool about their approach. They're not just running simulations on a computer. Their whole philosophy is about getting their hands dirty. They validate their ideas by building real hardware, actual prototypes, and putting them out in the real world. If it doesn't work in reality, it doesn't count. Simple as that.
And here's how they do it. It's this really smart co-design approach. It's a three-step dance. First, they design the actual circuits, the tiny brains. Then they integrate those circuits into a working system. And finally, they write the smart algorithms that make the whole thing intelligent. The best part is, it's a loop. What they learn from the algorithms helps them design better circuits, and so on. It's this constant cycle of improvement.
Okay, so to make this huge vision a reality, you've got to have a strong foundation, right? Let's look at the core research pillars they're building on.
First things first, power. You can't have a million little robots running around with a million tiny extension cords, right? So they have to figure out how to make these things talk to each other using almost no energy. Super efficient, low-power wireless networking is absolutely crucial. Next up, the devices themselves. They've got to be super small, super cheap, and barely use any power. And a huge part of that is creating what they call crystal-free systems. You know those little quartz crystals in almost all electronics that keep time? Turns out at this tiny scale, they're actually kind of big and suck up a lot of power. So getting rid of them is a massive breakthrough for making things smaller and more efficient. Then you've got this problem. How in the world do you keep track of millions of tiny things? You're not going to install a GPS unit on each one or set up cameras everywhere. That's just not practical. So they're building systems where the devices can track each other with no external help needed. That's what infrastructureless is all about. It's a total game changer. And of course, these little things have to be smart, but you can't have them constantly sending data back and forth to the cloud. It's way too slow and uses too much battery. The solution? Put the AI right on the device itself. That's Edge AI. It lets them think and make decisions on the spot, instantly. And finally, you put all those pieces together. The low power, the tiny hardware, the tracking, the onboard AI, and what do you get? You get swarm intelligence. This is really the ultimate goal, getting all these individual little robots to work together like a single super smart organism. Think bees or ants, but for technology. All right, so that's all the theory, but what does it look like in practice? Let's move from the what to the how, because this is where things get really, really cool. Let's just look at tracking to see what a difference this makes. The old way? You need fixed cameras, expensive anchors, it costs a ton of money, and it's a nightmare to scale up. The atomic approach? It needs, well, none of that. It works without any of that fixed infrastructure, which makes it super cheap, easy to deploy, and built from the ground up for massive scale.
So what can you actually do with this kind of technology? What does it unlock?
Well, it lets you do something that honestly sounds like it's impossible. It lets you track a single hornet
in the wild using one of their tiny crystal-free devices. This one little example pulls everything together: the incredible miniaturization, the super low-power design, and that infrastructureless tracking we were just talking about.
And I just want to be crystal clear here. This is not a concept drawing. It's not a computer model. This is real. They built the hardware, they put it on a Hornet, and they tracked it. This is their philosophy in action.
And tracking hornets, which is huge for things like protecting bee populations or dealing with invasive species, is really just scratching the surface. They're using these same core ideas for all sorts of things: building swarms of tiny robots, getting multiple devices to run large language models together, and even using regular old Bluetooth signals in new ways for sensing. It's wild.
Now, obviously, technology this advanced doesn't just invent itself, it takes brilliant people. So let's talk about the team behind the vision.
The Atomic Lab is basically this amazing hub for innovation, pulling together a whole team of researchers, PhD candidates, and master's students. They're all working together, tackling these massive challenges to bring this future to life one tiny micro thing at a time.
So all of this research really leaves us with one huge, mind-bending question. It's not just about the tech itself, but what we could do with it. Just think about it. What huge problems in medicine or in monitoring our climate or exploring new places could we finally crack if we had a million tiny things all thinking together?